Hey, geometry students. All right, so we've already done question A for the lesson practice when we used GeoGebra to make a graph for us. Actually, we had it draw the figure ABC, our triangle, and then the in center point D. That would have been really difficult to do with a compass and a straight edge, but you can do it. And it actually does teach you some valuable skills that are worth knowing using a compass and a straight edge. So, by all means, you can use a compass and a straight edge to answer number one by getting a piece of graph paper, putting those points on the graph paper, and then just using the construction method we learned to find the angle bisector of each of the three angles of the triangle and finding where all three of them cross. Technically, if you just need to find the in-center, you only need to know where two of them cross. But it's nice to do all three to make sure that they all cross at the same point, and then you're sure you did all your measurements correctly. So you can do that. It's going to look like either this triangle that I copied from GeoGebra, the one that we made, or this is the one that shows in the book. Notice this one's a lot more subtle, that this angle bisector is not perfectly on a horizontal line. It kind of looks in the answer in the book that this one is on a horizontal line, but actually it's inclined a little bit, and n is above 1, not on 1. So the correct coordinates of the in-center, which you did not have to give, but we know from GeoGebra the correct coordinates were 0.68 and 1.14. You just have to draw the in-center. So feel free to use whichever method you would like when you come to a question like that. Letter B, this one is the most straightforward question in the whole lesson because this one just uses theorem 38.1, which is really simple. All we have to do is set up a proportion, and our proportion is going to be 10, this side, compares to the side in the same triangle, 6, okay? So I'm going to say the long side, the hypotenuse, kind of, but it's not a hypotenuse because it's not a right triangle. It's really just the long side of the triangle compares to the short side of the triangle that's not the intersecting side, not the included side, right? Or not yeah, that would be an included side. The ratio of those two is going to be the same as the ratio of those same two sides but in the other triangle. So it's going to be the ratio of TU, the long side here, over 4, which is the short side here. All right, and then we're just going to solve this like a proportion. We cross multiply. 4 times 10 is 40. 6 times TU is 6 times whatever the length of TU is. Divide both sides by 6. TU equals 40 over 6. And then I simplify my fraction. 20 over 3. Let me just make sure that I did that one correctly. And whoop, bam, I did that right. Letter C, letter C, letter C. Oh my goodness. So there is a brute force method for doing this. If you use the brute force method, what you would have to do is find the line that contains two sides of the triangle. You have to find the line that contains 3, -1, and -1, -4. How could you find the equation of a line that contains 2 points? Well, you'd have to find the slope between those 2 points using the slope formula. You know how to do that. Then you have to plug the slope into the slope intercept form of the equation and plug in one of the points to find the y-intercept. And then once you have the slope of the y-intercept, you know that line. Now you have to find the midpoint between those first 2 points, right? And the line that's perpendicular to the line containing these points that passes through the midpoint. Now, you probably say in your head, yeah, I know how to find a line that passes through a point, and I know how to find a perpendicular line now. I have to use the negative reciprocal of the slope, but that's going to be a lot of work, Mr. Z. And yes, it would be a lot of work. And these are still going to be a lot of work, but here's what I'm going to suggest. Start with graph paper. Start with graph paper, and then just logically think through your triangle. If you can't logically think through your triangle, you're going to have to resort to the brute force method because I have to teach you a sequential way to solve this problem when you come to any kind of problem like this, okay? And the brute force method always works. It's just a pain. It will take you half of your lifetime to get the answer for one of these, okay? So instead, what we're going to do is I'm going to use my version of graph paper, and I'm going to look at the triangle. Now, again, you are not using GeoGebra for this. You have to use graph paper. I am only using GeoGebra because that is my online graph paper. So I'm going to put the points 3, -1, -1, -4, 3, -1, 3, -1, -1, -4. Okay. Oops, hold on. That's wrong. Delete. All right, and let me just make sure. So 3, -1, -1, -4, -3, -1. So we should see that two of these points are going to line up in one of the dimensions. That's Saxon's way of being nice to us on these problems, okay? Hey, I noticed that AC is on the line y equals -1. So that's going to make it pretty easy to find a perpendicular bisector for AC. Saxon's also going to do something else really nice for us with AC that he doesn't have to do, and it's just a feature of this. Okay, so here, let me just connect these so that we can look at our triangle. And remember, I need to find the perpendicular bisectors of all three perpendicular bisectors of these lines are going to intersect at the incenter. Circumcenter, sorry, circumcenter. Incenter is the other one. They're all three going to intersect at the circumcenter. But really, I only need to find where two of them intersect. And then I just know that the third one actually does also intersect. Okay, so let's think about this for a second. What is the midpoint of AC? I can do this by inspection. I could use the midpoint formula if I wanted to, but I don't have to. -1, -2, -3. So C is 3 to the left of the y-axis, and A is 1, 2, 3 to the right of the y-axis. So what's the midpoint? 0. And if the midpoint is 0, and notice that this line's also perfectly horizontal. That means that the line that's perpendicular to this is going to have an equation that you can just figure out from inspection. What is the equation going to be? Well, the line that's perpendicular to this is going to have the equation x equals 0. X equals 0. And that's going to make the rest of this really easy for us too. All right, we need to pick one of these other two lines that we're actually going to process, okay? So we could do BC, um, BC as it is on here. Okay, those are my 2 points that have two negative coordinates, -3, -1, -1, -4. Let's do those because it's going to be easier to work with 2 points with all negative coordinates than it is to work with one of my points that has a single positive coordinate. So let's do that. So what I'm going to do for letter C, I'm just going to note that one of the lines has to be x equals 0. That's going to be one of my perpendicular bisectors needed to find the circumcenter. I need to find another perpendicular bisector line needed to find the circumcenter. All right. And the way I'm going to do that is I'm going to take my 2 points that are all negatives, these two, and I'm going to use the midpoint formula to find the midpoint between them. To find the midpoint, I'm going to just do -1 plus -3 divided by 2. That's going to give me -2 because -1 plus -3 is -4. Divided by 2 is -2. -4 plus -1 is -5. Divided by 2 is going to be -5 over 2. Let me just make sure that this is a realistic midpoint. -2, -5 over 2. So for this line, 1, 1, 2, and then 5 over 2 is the same as 2.5. Could this really be the midpoint of this line right here? Yes, that looks like it's a good midpoint. Okay, so I just inspected my graph to make sure that this seemed realistic. Now I need a line perpendicular to the line that contains these 2 points that passes through that midpoint. Still a big ask, but it's way better than having to do this twice because one of my lines was horizontal. It was easy for me to figure out the perpendicular bisector line without doing a lot of work. So let's figure this one out. My midpoint is that, and then I need an equation in the form y equals mx plus b. That means I'm going to need to find the slope of the line between these 2 points. Well, that's not too hard. So it's going to be, and let me make sure I use a lowercase m. That's going to be y2 minus y1, -1 minus -4. -1 minus -4 is -1 plus 4, which is +3, over, and then in the denominator, -3 minus -1, which is -3 plus 1, which is -2, um, which is the same as -3/2 as my slope. All right, now I'm going to go ahead and plug in this slope up above here, but am I going to plug in -3/2? You notice I plugged in 2/3. That's because the slope of this line has to actually be the perpendicular to the actual side. Okay, so this is the slope of the actual side. I need to find the perpendicular bisector, which is the perpendicular line. And what's going to make it perpendicular is the opposite reciprocal slope that passes through the midpoint. And that's the last thing I need to do is I need to figure out how I'm going to make this line pass through the midpoint. I don't know what B is. I can calculate B of the line that passes through the midpoint if I plug this in for X and this in for Y. So let's go ahead and do that. So here I have -5/2 plugged in for Y and -2 plugged in for X. And I'm going to simplify this by multiplying in this -2 to the 2/3. That gives me this expression. I need a common denominator in order to do the next step. I need to add 4/3 to both sides of this to get b by itself. My common denominator is going to be 6, so I need to multiply this by 3/3 and this by 2/2. And now I can add 8/6 to both sides, and I get b equals -7/6. -15 plus 8 is going to be -7, and then over 6. All right. That is my y-intercept of the line that passes through the midpoint. My equation for my line that passes through the midpoint then, let's just think about this. One of my equations for a line that passes through the midpoint, a perpendicular bisector of one of the sides of the triangle, was x equals 0, remember. And then I have another one, y equals the slope 2/3 x minus 7/6. I put these two equations together, I should get their intersection. And when I find the intersection of these two equations, I'm going to have the point at which they cross, which in this case is going to be the circumcenter. So I'm going to plug in 0 for x. Well, that's super easy. If x equals 0, that means that y equals -7/6. So my circumcenter is the point 0, comma, -7/6. A lot of work? Yeah. These are going to be a lot of work. Let's take a look at this other one. D. A restaurant owner wants to place his new restaurant on equidistant from 3 nearby grocery stores that will supply him. They're located at A00. Oh, that's going to be a breath of fresh air. B40 and C06. Where should he place his restaurant? I'll bet this one we can solve just by inspection. So I'm actually going to delete everything that we have here. There we go. Oops. I am actually going to delete everything we have here. There we go. All right. And then I am going to plug in those points 0, 0, 4, 0, 0, 6. So we are going to do 0, 0, 0, 4, 4, 0, sorry, 4, 0, 0, 6. And this is going to make a nice, easy to solve right triangle problem. There we go. Okay. So I should have now all of my points here. Let me just zoom to where I can see them. Let's go ahead and connect these with segments, and then we'll take a look at what we're going to be dealing with as we figure out our circumcenter. Remember, the circumcenter is going to be the point that if he places his restaurant there, he's going to be equidistant from all three vertices. So I just put all these businesses at the vertices. Let's find the circumcenter that makes them equidistant. Well, okay, this perpendicular bisector of the hypotenuse is going to be kind of tough to figure out. But I'll bet the perpendicular bisector of this line is going to be really easy. What is it going to be? Well, what's the midpoint of 0 between 0 and 4? It's going to be 2. So my perpendicular bisector is going to be on the line x equals 2. That's that vertical line here. And then of my on this side, my perpendicular bisector is going to be on the line y equals 3. Where does the line x equals 2 cross the line y equals 3? If I put those together, just listen to it. X equals 2, y equals 3. I don't have to do any other work on this one. With a right triangle, the circumcenter is going to be on the hypotenuse. And in this case, it's going to be 2, comma 3. And that's it. I did that one entirely by inspection. So I could say that the answer to D, and I just went off the page. Hold on. Let's just go over here. D is 2, 3. That one is super simple. And that's it. That's all I have to do for that one. That is my circumcenter. All right. You are ready to do hard problems and easy problems on the lesson. So do the lesson for next time.